Okay, so tonight's video concludes our videos about the distributive property. This will be our final strategy that we can learn as a way to show and use the distributive property to multiply. So again, we are still applying or using properties of our multiplication operation as a strategy to help us multiply. And tonight we're going to be working on partitioning our own area models to show the distributive property. So the video before this one was picture arrays that were already distributed for you. They already had that big line dividing up the whole array. So tonight we're going to show you how to do that on your own. So here's our first example, and yes, we've used 3 times 9 before, so we're going to use it again. And this is a good example for how to use the distributive property to partition or split an array. So in this case, we're going to take the 9 and decompose it because it's a much larger number. I'm going to decompose my 9 into 5 plus 4 because I'm good at multiplying by 5s. So I'm going to put that in parentheses because those are the two digits that when you add together, they give us our larger factor. So we can use this distributive property to break down this one large array into smaller multiplication facts to make it easier to solve. So we know that we're going to have to distribute the 3 to the 5 and to the 4. So I'm going to go ahead and write my first one, 3 times 5 on this side, and I'm going to write my other one, 3 times 4 over here. Okay? So what you would do is take this array that's already drawn for you. This already shows the entire array, 3 times 9. This picture right here. Okay, this shows us 3 times 9. 1, 2, 3 times 1, 2, 3, 4, 5, 6, 7, 8, 9. But if we wanted to show how we distributed this 3 times 9, then we would need to partition or break up this array into 2 separate arrays. And that's where 3 times 5 and 3 times 4 come into play. So first I'm going to create the array for 3 times 5. So I know I need 3 rows and I'm going to need 5 columns. So I'm going to go ahead and number that out to 5. Once I've drawn out my exact number of rows and columns for 3 times 5, I'm going to go ahead and box that off to show that that is my first array. Then I'm going to look at my next multiplication fact that was distributed, and that's 3 times 4. So I know again I need 3 rows, and I'm going to need 4 columns, and I'm going to go ahead and block that off. So now you've done, in fact, what the picture below has already shown. You have shown the array for 3 times 5. You've shown the array for 3 times 4. And if you look at the picture below, you can see that 3 times 5 is 15, 3 times 4 is 12, and 15 plus 12 is 27. Therefore, 3 times 9 equals 27. All right, so now, here's another example. 8 times 7. So in this case, I'm going to go ahead and decompose my 7 because I can break that 7 into a 5 plus a 2, and both of those are way easier for me to multiply than if I decompose the 8 into a 5 and a 3 or a 4 and a 4 because I don't know my 4s very well. So I'm going to decompose the 7 in this case. So that lets me know that after I decompose the 7, the next thing I'm going to have to do is distribute my 8. So that will give me 8 times 2, 8 times 5, and then 8 times 2. All right, so the first thing I'm going to do is want to take 8 times 5 and split up this array. So I know I'm going to need 8 rows, and I'm going to need 5 columns. And you know you could do that either way if you would like, okay? But I'm going to go ahead and do rows, 2, 3, 4, 5, 6, 7, 8 rows. And 1, 2, 3, 4, 5 columns. I'm going to go ahead and box that off. Okay, now I'm going to come over here to 8 times 2 and make sure I have 1, 2, 3, 4, 5, 6, 7, 8 rows and 1, 2 columns. I'm going to box that off. So I know that 8 times 5, if I count by 5s, or if I count every single box in this mini array, I should get a total of 40. And if I count or multiply or skip count by 2s 8 times, or know automatically that 2 times 8, what that product is, then I should get 16. So if you add 40 plus 16, you're going to find your total product, which is 56. So 8 times 7 is 56. That means this entire area model has an area of 56 units. So at this time, I would like for you to pause the video and try 9 times 3. If you're not sure of what to do, then go back and rewatch the beginning. And when you're ready, pause and do this one on your own. Okay, so the first thing that I would do is decompose the 9 into 5 and 4. Okay, next you're going to distribute your 3 to the 5 and the 4. So that's going to be 3 times 5 and 3 times 4. So what you want to do is do 3 rows and 5 columns, or vice versa. It looks like I already have, for this multiplication fact, I have 1, 2, 3 columns, and now I need to go 5 down. 1, 2, 3, 4, 5, and I'm going to block that off. Okay? The next thing you'll need to do is then go to your next array, or your next multiplication fact, which is 3 times 4. You have 1, 2, 3 columns, and now I need to count 4. 1, 2, 3, 4, and you can block that off. So this time our array is cut this way. All right? So then you would need to find the product for 3 times 5, and that's 15. If you counted each of the squares inside this array, you would get 15. And then you need to solve what 3 times 4 is. And if you count all of these squares in this mini array, or you know 3 times 4, then your answer is 12. So you would bring both of those totals down. 15 plus 12 equals 27. So 9 times 3 equals 27. Practice problem 2 is 7 times 4. Please pause to solve 7 times 4. If you did not get the first practice problem correct, go back and rewatch my explanation and make sure you understand that before you try your next problem. Okay, 7 times 4. Here we go. We're going to go ahead and decompose our 7 into 5 plus 2, because I can multiply by my 5s and I can multiply by my 2s. Then I know that I need to distribute my 4. So I have 4 times 5 as my first fact, and 4 times 2 as my second fact. So I'm going to now take 4 times 5 and create an array. I see that I have 1, 2, 3, 4 columns going across, so now I need to go down 5. 3, 4, 5. Block that off. And my next array is 4 times 2. I already know I have 1, 2, 3, 4 going across, and 1, 2 going down, so there's my second array. So to find my answer, 4 times 5, I count by 5s, I can get to 20, or I can count each of the squares in this first array to get 20. Then over here I'm going to solve 4 times 2. I know that one is 8, but if I didn't, I can count 1, 2, 3, 4, 5, 6, 7, 8 in that array. Then you're going to take your 20 plus your 8 to get a total of 28. So that means that 7 times 4 equals 28. If you are still confused, please feel free to rewind, fast forward, rewatch, redo, however you need to. If you still have questions in the morning, please let Ms. Hallmark know first thing. Thank you.